Hello class, this is a video tutorial on the integration of the exponential function. Knowing that d on dx of e to the x equals itself, this one here, we can easily conclude that the integral or integration of e to the x, well, is itself plus c. What is not apparent are integrals of other powers of e. So for example, if we had a linear power of x, so ax squared plus b, there's no squared or cubed on this, so it's just a linear power. The integral, or the integration of e to the power of a linear expression is itself divided by the coefficient of x, and always plus c for an indefinite integral. But generally speaking, with more difficult integrations, if you have e to some power of u and its derivative, so the derivative of the power is a coefficient of x, the integration of this is e to the u plus c for indefinite integrals. And we'll get into a few examples of those in my next video. Now, a little tip that I've learned is that if ever you're unsure of your integration, differentiate your result and it should be the original question. So take, for example, let's say we had this question here. We were asked to integrate this and we came up with this answer. If we differentiate our result and we came up that, oh, it's matching the original question, that means that this answer is correct. But if we, let's say we had a different question, we had this integration and we came up with this result, we differentiate the result and it came up that it's not exactly matching our original question. Notice how there's a 2 missing here, which means that we went wrong somewhere. We could either correct it or do the whole question again. Right, so that's a little tip for you. But let's get straight into a few questions and a few examples here. So here we go. So for this, we always just take the function that we see, e to the power of 2x plus 1. Okay, so e to the power of 2x plus 1. This coefficient is going to just multiply our result. Now we're going to have to divide by the coefficient of x because this is a linear expression, so it's going to be 1/2. The 2½ will cancel, leaving us with e 2x plus 1 plus c. Let's do another example here. Again, it's going to be the exact same expression, e 3x plus 5, but we're going to divide by the coefficient of the linear expression. I'm going to emphasize that because there's not a squared on the x or a cubed or anything like that. It's just a linear expression, so we're dividing by the coefficient of x, so 1/3 plus c. Just as a note, you may see this as a result sometimes, 3 to the x plus 5 over 3, which these two mean the same thing. Oh, and plus c. Whenever you have multiple expressions, and notice how there's no multiplication here, they're all separated by plus or minus, we just integrate each individual component. So the integral of a constant is just x. The integral of this, we raise the power by 1, so x squared, dividing by the new power. For this one, it's the exact same, because remember this is e to the x, this is the exact same expression dividing by the coefficient of the linear expression. So we're dividing by negative 1 like this. So it's originally a plus, but plus divided by a negative 1 becomes a minus, plus c. If we have just e to the x, that's nice and plain and simple. Actually, let's do it here. That's e to the x. But now, because it's a definite integral, we're going to substitute from 0 to 2. Oops, 0 until 2. So we're going to substitute e to the power of 2 minus e to the power of 0. I'm just going to leave this in exact form as e to the power of 2 minus 1. Remember, this is an area, so we'll say that... Oh, actually, no. This is not an area because we're only asked to evaluate this integral. So this is just a number, and we'll just leave it at that. Here we go. If ever you're confused with the order of these, I always like to have my x's in the front of the powers, so I'm going to rewrite this as e to the power of negative 2x plus 5 dx. This is just to help me visualize my integration. You don't have to do this if you don't like. Now for this, we're going to integrate. It's going to be the exact same expression divided by the coefficient of x. So divided by 1 on 2, but it's negative, so negative half. And because this is a definite integral, we're just going to evaluate from 2 till 3. I'm going to factor out the half, so half from the outside. This is now going to be e to the power of negative 6 plus 5, substituting 3 into x, minus e to the power of negative 2 times 2, so that's going to be negative 4. That's negative 4 plus 5. The half stays where it is. This will be e to the power of negative 1 minus e to the power of 1. Now, don't be confused. This does not become e to the power of 0. That is only true if this was a multiplication. So this is actually our expression here. I'm just going to leave it as negative 1 on 2e plus e on 2. In actual fact, by doing this, if you're wondering how I did that, this is a negative indice, so it goes to the bottom. This is just e to the power of 1, so negative half times negative e is positive e on 2. And we'll simplify this. This will become all over 2e negative 1 plus e squared. And I just noticed that this needs another e, so this second one was multiplied by e. Cleaning this up, we get e squared minus 1 on 2e. Okay, so that concludes just the basic integrations of linear powers of x. Okay, hope to see you in the next video where I do integrations of slightly harder powers of x. See you then.